Hi, my name is Ghaus Malik. This summer, as a part of the Young Scientist Program Planetary Habitats Project, I used AI image generation tools to imagine how around 100 people might live on the moon. My goal was not only to make images but to think about what a real habitat needs to survive, like shelter, food, power, robotics, mobility, and like human well being. This was the my initial habitat map. I designed the base as connected system rather than just separate buildings. It includes buried residential areas for radiation protection and community center, medical and research spaces, and food production, power generation, water recycling, oxygen extraction, mining, construction zones, airlocks, and emergency shelter as well. This helped me think of lunar habitat as a small city where every system depends on the others. One important shift in my thinking was that a habitat is not only about survival equipment, people also need social place, routine, and comfort. This community center represents a central place where residents could meet, eat, work together, relax, and stay physiologically connected. During a long missions for a group of 100 people, the design has to support both operations and a human well-being. The personal quarters were another key concept in a small lunar settlement. Like privacy would be limited, so each residence need a compact but meaningful personal space. I imagine a room with a bed, workstation, storage, personal photos, and plants, and a window view toward Earth. The key idea is to make basically environment humanly, not only mechanical. Food production was one of the most practical parts of the design. Our lunar habitat for 100 people can't basically depend only on deliveries from Earth. Hydroponic agriculture technique could provide fresh food, help support life systems, and create a more natural environment for the crew. It also gives residents a meaningful daily work and a visual connection to the living systems. Robotics become essential in my final concept. I imagine a robotic assistants helping with everyday work, not only the large construction tasks. Inside the habitat, robots could carry supplies, inspect services panel, help with repairs, support medical or laboratory logistics, and reduce repetitive work. This would let the human crew focus on higher level decisions while keeping operations safer and more efficient. Outside the habitat, robotic constructions and resource extractions would support long-term growth. This scene shows mining, equipment, and construction machine would working around the settlement. The goal is to use local lunar material for shielding infrastructure, possibly oxygen or other resources, so the colony becomes less dependent on everything coming from the earth. Transportation is critical because a lunar settlement would not be limited to one building. Imagine a pressurized human transport vehicle that mainly drives like a rover but also has a limited hopping assist capability for different terrains. Yeah, so this was a video. Let's watch it together. By the end of the project, I realized that designing a lunar habitat really about is really about designing an entire living system: shelter, food, energy, robotics, transportation, resources, community spaces, and even personal privacy all have to work together. And for me, one of the most interesting lessons was that AI wasn't just useful for the creating futuristic pictures. It became a way of rapidly visualizing ideas, questioning them, and then improving the design to finish. I want to show some of these concepts could actually feel in the motion. Like as you can see that the images, the videos are of the same images which I showed you earlier. This is the transportation vehicle, which can obviously can go view and over some crater as well. This is the closing scene, and from isolated outpost to a living community, this is my vision of how humans could begin building a home beyond Earth. Thank you.